Good afternoon. This is Group 8, Kristen Parkinson and Joseph Hughes. We are going over Chapter 14, Create Telemetry to Enable Seeing and Solving Problems. In this chapter, we learn about telemetry and having enough telemetry in the right places so we can confirm that our services are correctly operating in production. That way, when problems do occur, we can quickly determine where and what went wrong and make decisions on how to fix it. For introduction, telemetry is automated communication process by which measurements and other data are collected at remote points and are subsequently transmitted to receive equipment for monitoring. Also, we're going to learn in this chapter why we need telemetry, how to use telemetry to track how changes affect areas of production, and why it should be highly visible. So we start off by monitoring the system as a whole, providing useful information in both development and operations. We can see problems as they occur and identify the problems quickly. By centralizing event logs for analyzing, the logs are transformed into metrics, which are then set to performance standards. Should changes occur that produce unexpected results, we can analyze the data and find the fault. Telemetry will be used in all of our production and pre-production environments, also used in our deployment pipeline. And we learned from NASA, who monitors every level of a launch with telemetry, that the mindset, if it was important enough for engineers to implement, it's certainly important enough to generate enough production telemetry so that we can confirm that it is operating as designed and the desired outcomes are being achieved. We do this by logging levels or logging entries into identifiable categories. Some of the categories we learned about were the debug level, which is where anything happens in the program, the info level, which is user-driven. Each department would have different areas that they would like to be informed of. There's a warn level, which could potentially cause an error, which is an error condition, and a fatal level, which we must end or terminate. And we use telemetry to guide problem solving. In this chapter, we can go back and learn and couple this with other chapters we've learned about that shared knowledge is knowledge for everybody. If we were to hide our telemetry in order to not play the blame game, it doesn't work. So we use the scientific method of asking a question and then building our telemetry around that. That way there is no blame game. We learn from our mistakes. We have a hypothesis and we learn from it all. By using telemetry, even when it highlights our failures, we are able to see and learn, and perhaps even more importantly, document how to solve the problem. So telemetry enables creation of production metrics as part of our daily work. We make telemetry easy to write into our everyday code. Part of this example was the StatsD, which is created and is open source by Etsy. StatsD renders metric events onto graphs and dashboards so that you can observe how code affects production. The graphs allow us to see an overlay of code deployment, when the code was deployed, and how it integrates and is working in the production deployment. This one is create self-service, access telemetry, and information radiators. The information radiator is the number of handwritten, drawn, printed, or electronically displayed places that the team can see the telemetry information in a highly visible location, so that all team members, as well as passersby, can see the latest information at a glance. That can include counts as automated tests, velocity, incident reports, continuous integration status, and so on. The idea originated as part of the Toyota projection system. We have in this chapter, or this verse, we have case study from LinkedIn. While they had telemetry, it was hard to retrieve the data. By starting gradually with Python scripts to help create a streamline of the process, and they were able to speed up navigation. They continued to add functionality, which resulted in graphics, which monitored functionality with web-based mail providers. They were also able to get most important results and could swarm and fix the problem in infographics and it's now prominently featured in their offices and online. We need to find and fill any telemetry gaps. So that means identifying the gaps that quickly impede resolutions to the problems. And this can be on multiple levels: the business level, application level, infrastructure level, client software level, and deployment level. By having telemetry at all of these levels, we can see the health of each area. This helps us to detect and fix problems earlier. With application and business metrics, we have, they're not only we need to make sure that all of our telemetry are actionable, meaning they just don't show what's going on. We are able to see what they are doing, where they're doing it, and it provides useful information. So the telemetry can generate from new users, logins, events, how long they were on the system, whether they went through to an order form. But pretty much with telemetry and metrics, we measure how everything is going on, and it all consists with our business goal, and every business goal can be actionable. The infrastructure metrics are just another puzzle piece. They generate telemetry that is organized by service or application, overlay telemetry to show correlation between the code and the production, and telemetry can be used in pre-production environments. By generating telemetry that is organized by service and application, we can pinpoint where and when something goes wrong. A direct correlation can be drawn between those. And by overlaying other relevant information into our metrics, we know that risk is inherent, but we can also see through telemetry when something occurs, so we can learn from that. To counter this, we make all of our work visible and available to all. And other objectives could be used, overlays for operations in all functions in our business. So in conclusion, telemetry is critical to quickly identifying problems as they occur. This is achieved through shared system, logging levels, and hierarchies. Application and business metrics can be utilized for organizational goals. Infrastructure telemetry organized by service or application. And with telemetry, it is easier to diagnose problems as they occur, as evidenced by the Etsy and LinkedIn examples that we learned from this chapter. Let us know if you have any questions. Thanks.